Hello everyone and welcome to a new Mendix community webinar. My name is Jan de Vries and I will be your host for today. Today's webinar will be about a beginner's guide to IoT and Mendix and will be presented by Simon Black, Technology Evangelist at Mendix. During the webinar, you can submit your questions in the question window in GoToWebinar. After the presentation, we will go through them one by one. The questions and answers will be added to the webinar page afterwards, along with a recording of the webinar. Before we start, please take a look at the handouts window in GoToWebinar to find the presentation slides. Thank you for joining and enjoy the presentation. I'll now give the floor to Simon.
Thanks, Jan. So in this webinar, what I want to do is I want to cover a number of things regarding IoT. So the first part, I want to give you an introduction into IoT and the landscape of IoT. So what type of technology makes up this landscape? I want to then take you through the device management, so what device management is, how you can use it. IoT brokers, so how those are influenced in the IoT and how those communicate and control the protocols. I'll then go into some details about MQTT as a protocol, show you an awesome demo of a IoT application, and then finally I'll show you how to actually build one of these IoT applications. So to introduce myself, I'm Simon Black, one of the technology evangelists from Mendix. I work with the evangelist team to build a critical mass of people and users within Mendix and spread the word of the technology. So the Internet of Things is obviously a hot topic at the moment. The Internet of Things by 2020 is supposed to have 30 billion devices. So everything from your toothbrush to your car will have an IoT device. And all of this IoT information will be streamed as data, and applications will need to be able to control that data and be able to react to that data to build experiences on top of these services. So the IoT landscape is obviously quite wide and large. We have to have a number of different components in order to build an IoT solution. The first one is you need to have some things. So you need to be able to monitor something like a car, a toothbrush, and so on. These are what I would refer to as things. Those things usually come with a number of sensors. Those sensors might be recording things like their temperature, the movement, velocity, and so on. And those sensors will stream data out to a particular system. We then have things like actuators and agents which will act more on the device side to be able to control certain things based on sensor information and based on triggers from the device. We have communication, so we need to have certain communication protocols in IoT because obviously these are streaming lots of data. They need to be small amount of packages and data packages so that they can make it very easy to communicate this information. So protocols such as REST, MQTT, ZigBee and so on, all are communication protocols designed for IoT landscape. And then finally, edge computing is all around building logic and computing into applications that are near the sensors. So if you imagine you have a number of sensors on trucks or planes, you want to be able to process that information as quickly as possible. So edge computing is all about creating those services close to the sensors so that they don't have to send that data off to the cloud, process it, and then react to it. So with IoT, and when you're setting up an IoT application, you need to have a device management. So lots of IoT services out there will provide a device management portal, and this allows you to do a number of things. It allows you to provision, authenticate certain devices, so using things like password security, certificate security to secure access to your devices. You then want to configure and control your application, so being able to configure those devices, being able to control them from one central portal. You want to be able to monitor and diagnose those sensor data and those information you're getting from those devices. And finally, be able to perform software updates. So update those software from one central portal, all of your sensors around the globe. So usually what these IoT services providers like AWS and Bluemix and so on provide is they provide two things. The first one was the device management, which I said about before. And the second one is an IoT broker. And what an IoT broker does is it's a lightweight and scalable middleware which allows you to communicate and control the communication between the IoT applications and the devices itself. So the devices will push information to the IoT brokers, and the applications will then listen into that information to react to those different communications and different information. Usually these brokers will communicate via two different methods. One is REST, which is a common protocol most people have heard of, but the other one is MQTT. So MQTT is very popular within the IoT space, allowing you to do very short and quick messages between your IoT devices and your broker portals. So a little bit about MQTT, that's what we'll use today as our demonstration. So it's a lightweight protocol for sending messages, and these messages are usually sent over topics. So a topic is essentially a hierarchy as delimited by a slash, and it will tell you information about what kind of sensor type it is, what location and so on. That information is then sent to the broker along with a payload of information, and that broker will then send out that information to the different devices that are subscribed to that broker. And with MQTT we have two methods. We have a subscribe and we have a publish. So subscribe means that we will listen in to any messages that get published to the broker, and publish is for submitting data to that particular broker. Okay, so the first part, what I want to go through is an actual demo of an application. So this is an application that we built for the IBM Interconnect event, which uses IBM IoT and is around the concept of logistics. So being able to track cargo ships and those containers and being able to react to the information from those particular containers. So I'm just going to switch to the demo now. So if we look at my dashboards here, I've got a dashboard of all of the information about my particular container. So I can see information about the movement, the temperature, light and humidity. And at the moment we've just got some static data in here. We can see the light level recorded over time, and we can also see some temperature information and so on. So what I'm now going to do is I'm actually going to start sending this application data to IBM Watson, and I'm going to be able to see that information populate in my application. Once I get an alert from the application, I can then start to do something about that particular alert. So let's have a look at the data. Let's send some data now. I'm actually going to push to the cloud some information. And this is actually coming from one of my live sensors. So I've got here a sensor with me, which is a TI sensor tag, which allows me to sense and view a lot of data about movement, light, temperature and humidity. So for instance, if I close my hands over the actual sensor, we'll see that the light now drops down to 0. If I open it up, we can now see that the light will spike. So obviously it's very important, especially in the logistics industry, that cargo is delivered in a consistent state. Things like temperature, light and so on can actually damage that cargo and have an influence on that particular cargo value. So let's actually try and trigger an alert in the application. So within the application, we've built the application to be able to handle certain events from our device. So if we actually shine a torch, for instance, at our sensor, we'll see that the light will spike up in this application to over 2000 watts. And we'll now get a push notification into our application. So this is obviously our web version of the application, but we've also built a mobile version of the application. And the mobile version allows us to view the same information, but it's for a person on the cargo ship. So being able to actually view that data live and be able to react to those events. So we can see at the top here we've got our push notification now, and we can view that push notification and start to drill down and see what occurred and what happened with that particular incident. We can swipe between different information like temperature, light, humidity, and drill down on that information to see what has occurred with it. So we can see previous history of all of that data that has gone on that particular sensor. As we've been going through, when the application triggers those alerts, it will also generate a blockchain in the block. So it will create a block in this blockchain to actually create us an immutable ledger of everything that's gone on when we've been actually creating these alerts. So we can have no disputes as to what has been happening with these particular IoT devices and what has been going wrong in the application. So this is a common trend that we see in the industry, is people starting to combine IoT and blockchain to be able to make sure that they can read the data and they can sense the information, but they can actually then record that so there's no disagreement in what's been going on those IoT sensors. Within this application, it's also created us an inspection. So within the inspection, we can see that we have had an inspection with light to high. And if we drill down on that inspection, we can see and start to enter some information into this inspection. So we can do things like take a photo, we can add in information about when the inspection occurred. So using some native dialogues from the device, like the camera, the calendar, the GPS location and so on. We can also set the location as well, so set a GPS location of where we are and where the incident occurred. If we now is to submit this inspection, we can now see that information and see a PDF version of that application. So what this application will do is it will be stored in Box technology, so we can have a central repository of all of our information, all of our inspections in one place. So if we go to the completed section now, we can see that we've got that particular inspection. We can view that inspection and we can see some additional information. So we can see the actual Box renderer here rendering our PDF, and we can see the information that we submitted about the longitude and latitude and what we've entered in as our information. If we'd added any pictures in here as well, those would be added into the information. So this kind of shows you how you can combine Mendix with these different services, whether it be IoT services, blockchain services, or Box technology for your document storage. Within the application as well, we've implemented the functionality of swipe functionality. So this is actually a widget that was added recently to the App Store. So being able to swipe away certain notifications in the application. So this is all of these functionality you can download today from the Mendix App Store. You can customize and you can add these to build your experiences in your applications. So that kind of gives you an idea of the type of applications you can build. But what the community team has been hard at work at has been taking this application we built as the evangelist team and being able to create this as an IoT tutorial as well. So this is something that is being released to the App Store at the moment. So you can go online today and you can take this tutorial and start to build out your own IoT application. And this is what I'm going to be using today for my particular demo, is I'll take you through the IoT tutorial and start to build and show you how you can use technology like MQTT to build your application. So if we look on the Mendix App Store under IoT, we have a number of connectors and modules. We obviously have the logistics tutorial, which will take you through a step-by-step journey to build your application. We have an AWS IoT connector, which allows you to specifically connect into AWS IoT. And we have a generic MQTT connector to use MQTT on a variety of different MQTT brokers, whether it be on Amazon or whether it be on IBM or SAP and so on. So to give you an idea of where you usually start when you start to build an IoT application, usually you will start with a device management or IoT broker. So let's take a look at one of those. So this is actually the IoT broker that we're using for the actual demo. So this one is based on AWS. And here we can see a dashboard of things like the number of connections, the type of protocols we've been using to actually communicate those messages, and the number of inbound messages and what types they are. Within each broker and each device manager, you can register a number of things. So things are what you're actually going to be monitoring. So it might be, for instance, a car, it might be an IoT sensor like we've got here today. And we can drill down on those things and start to set those up. We can set the details up of them, so we can give them information about what type they are. So each device will usually have a type, and that type describes what information you can pass to it, what details it has, and what type of actual application it is, what sensor it is. Within here, we can also set up security as well. So one thing you have to do with AWS is you have to use certificates to be able to secure your access and send data and receive data from those devices. Other IoT brokers like the IBM Watson, for instance, or the SAP portal as well, allow you to do this without having to do certificates. So simply by a password, for instance. If we look at some other examples of IoT brokers, you can see the same sort of patterns in each of them. So if we take a look at the IBM Watson IoT platform, we have the same concepts. We have a list of devices, which then have a list of a type, and those devices can then send information to those particular patterns. So we can see, for instance, here we've got some devices already connected, which are actually sending data to the actual portal. So once you've set up your devices, you've communicated those, set those up in the IoT portal, you can then start to connect to those in your Mendix application and start to use that data. So let's actually take a look at our Mendix application and let's start to actually implement the actual features. So if we just switch now to our local machine. So this is actually the IoT tutorial that's now available on the App Store. And when you first come into the application, you can select a shipment. But what you've also got on the top here as well is a view tutorial. So if you click on view tutorial, this will then take you into the documentation and give you a step-by-step guide on how to connect up your application into our example IoT service. So we've already hosted an IoT service for you, which you can connect into to use as an example and start to use that data. So if we drill down on the shipments, we can see that shipment and we can see the same sort of data that we had in our example data on the example application we showed earlier. But at the moment, the data we've got here is static. It's not collecting any information from our IoT service. So we actually want to connect this up now. We want to do what's called a subscribe. We want to be able to subscribe to the information from the IoT service so that we can get any of the updates that are being published to the AWS broker. So if we go into our modeler now, we can open up the modeler and see the same page that we have open on the desktop. And we can start to add in the functionality that we need to be able to subscribe to that data. So the first thing we want to do is we want to add on a button so that we can actually subscribe to that information. So I've already got a microflow set up here for the subscribe, which I'll go through in a second. And if we drag that onto our page, we can now have a button to subscribe to that information. But let's have a look at what that actual microflow is doing. So these first parts are just some checks to make sure that we've got the right information, the right topic, and the right configuration so that we can retrieve it and we can then send that to our subscribe method. So we've now got an activity here for the AWS IoT, which allows us to subscribe to any MQTT topic. If we drill down onto those properties, we can see that we have to set a broker host. The broker host is essentially the URL of where you're actually going to send this information. We've got the broker port. Usually this is 1883 if you're using MQTT, but you could have set this up on a different protocol to use, for instance, different security and so on. We then have a timeout, which will allow us to, basically if we can't get a connection, it will time out after a number of milliseconds after trying. Then we have the topic name. So the topic name is actually where we're going to actually subscribe to. So in this case, it's a hierarchy, and we'll show you later when we come to publish what that topic kind of looks like. We then have the on-message microflow. So this is important, especially when you are receiving data. You want to be able to process that data. So we've hooked this application up to a microflow so that when we receive data from our MQTT, we will then be able to process that data. So if we click on show, we can show this microflow. And it simply has two parameters, and at the moment we're just logging the information. So these parameters are important because you need to have a topic string and also a payload string. So the topic will tell you where you're sending it from and where it's coming from. The payload will tell you what information is being sent. So usually this payload is sent in JSON format, but it could also be in XML format as well or some other format. Essentially, it's just a string of data that you're sending the actual application. So what we can do now is if we run this application now, we can actually subscribe to the IoT service and we can then see the information in our log lines. So So when we click the button on our application, which should be now updated, here we go. So we've got our subscribe button. If we click subscribe, this will now subscribe to the topic completed device 1. So we've got the information here. It said it's completed. If we click OK and we go back into our modeler, we can see in the console that we've started to get information from our IoT service. So here we go. We've got sensor data received. We can see the payload, which is in JSON format, and we can then start to use that information. So let's actually use that information in our application. Let's take an example payload and let's start to use that data. So we actually want to map that data and store it in the Mendix application so that we can then update this dashboard. So at the moment this dashboard is just using historical data, but we want it to be able to use live data in the application. So let's connect that up to actual data now. So what I'm going to do and show you is how we can actually take a JSON payload from our application, how we can build a mapping, and how we can then use that mapping when we call that service and we can process that data. So now let's copy this payload into our application. So if we go into our application now, we can now start to create ourselves a JSON snippet. If we right click on any of the folders, we can select Consume Services and JSON Structure. So within here we can paste our JSON snippet. So what data are we actually going to receive from our IoT broker? We can click refresh and it will automatically detect each of the types of what the data is. So now we've created a structure, we now need to create a mapping. So we need to now be able to map that data that we've got in the structure to our own database. So again, if we click Add and we click on Import Mapping, we can now select a JSON structure, which we've just created earlier. And we can select all of the items that we want. At the moment, we want all of them. And it will now bring up this dialog for us. So at the moment, these are highlighted in red. And that's because we haven't mapped those up to a data model in our application, to an entity that is existing in the model. So if we need to actually map that up, we can drag from our connector. Usually this is on the right hand side. It might be somewhere else for other people. We've already got a sensor data entity. We can simply drag that onto here and it will ask us then to select each of the items that we want to map this up to. But I don't want to have to manually map each of those, so I'm going to map those automatically. If we click Map Attributes by Name, it will automatically detect which attributes it needs to map it up to, and it will then map those to the data items. If it was a new entity, it can automatically create those attributes for you, so you don't need to have to create each of those attributes and each of those entities available for you. Okay, so we've now got our structure, we've got our mapping. We now want to change this microflow so we can import the data and we can see that live in our dashboard updating. So let's delete the log lines and let's add on 2 new activities. The first one is we're going to do an import mapping. So we can import with mapping. We're going to select the payload, which is as a string, and we're going to use the mapping, import mapping 2, which is the one we've just created. We can then decide to store that in a variable, which will allow us to actually see that data and do something with it. So in our example, for instance, that we showed earlier, what I was doing is I was using that sensor data and making some decisions within the microflow. So we can add on certain things like exclusive splits to say, okay, if the sensor data and the accelerometer is greater than 100, for instance, then we could then do something in the application. We might want to trigger an alert, a push notification, for instance, like in the example we showed, or store some information and alert in the application. So now once we've imported the application, we need to do one more thing, which is actually save and refresh that data. So I'm just going to drag on an existing microflow that's already pre-built. All this microflow is doing is it's just making sure that that data that we've retrieved is saved against the right information and right shipment that we're using. Again, all of this information is available in the tutorial, and it's a step-by-step guide on how to actually use it. So I've got a couple of errors which I need to just fix. I need to give it some data. So I need to say the topic that I'm giving it and also the sensor data. So let's rerun this application now locally, save our changes. And now when we run this and we subscribe to the information, we should start to get live information from our sensors in the application. Here we go. So if we open up the application now, we can see our shipment. We can drill down on it. And now when we hit subscribe, we should start to see information be populated in our dashboard. So we should see the light level go, and we also should see some information in the actual graph as well change. So actually with this particular data, we're connected up to the example IoT broker on AWS, which comes with this tutorial. So you can easily connect up and start demoing and using these IoT services. Okay, so I've obviously showed you from at the moment, I've shown you how to subscribe to the data. So how to actually connect up to the broker and view that data. I've shown you how to actually map that data using the JSON mapper. And then finally, the last bit I want to show you is actually how we do the second method of MQTT, which is publish. So how do we actually submit data to the broker, and how does that then influence the data we've got here? Because at the moment we've not got much change in the light. We might want to trigger a light alert, for instance, and trigger it so that it goes above 3000, 4000, for instance. So let's do that now. Let's switch back to the modeler, and let's create a new flow for that as well. So I've already created a mic flow for this, which allows us to publish. So it will retrieve the topic that we want, retrieve the configuration, and we've now got a different type of mapping. We've got an export mapping. So if we take a look at the data now, we can see we've got similar sort of data that we're sending it in a JSON snippet, but instead of an import mapping, we've got an export mapping. It does the same as an import mapping, but the other way around, so it will export rather than import. If we go into the mic flow again, we can see that we've got a similar connector here, but this one is actually for publishing. And the only difference here compared to the subscribe is that we're actually sending a payload here. So we're actually sending data to the IoT service so that we can then see that data in our dashboard, because we're actually subscribing to that data. So let's go to our page again, and let's drag on these published data. If we drag on the published data now, we can now connect this page up so that we can start sending it new data to the service. So let's actually change the data that we're going to send. We're going to send a light level of, let's say, 4500. Click OK. And rerun this application. What it will now do is it will start to send that data to the IoT service. So if we go into the shipments now, we can see that we've got one shipment still. We can drill down on it. If we first subscribe, what we usually do with the subscribe method is we actually put this in an after startup flow so that we don't have to keep clicking the button every time. But for the demonstration purposes, I just wanted to show how we can actually subscribe to it. So if we click the button now, publish data, it will now trigger some data, send that to the AWS IoT. And because we're subscribed to that data, we'll now get that information. Any other application that's subscribed to this data as well will also get that information as well. So you don't have to, it's not a one-to-one binding. You can have multiple systems communicating, using and subscribing to the same topics, and also multiple devices submitting to the same sort of topics as well. Usually you would have one topic per device so that you could then make it unique so you know where it's actually come from. Okay, so they subscribes actually being able to listen into the data that's being coming from our IoT broker. The second one was being able to actually process that information that we've got from the IoT broker and use the import mappings from Mendix. The third one is finally obviously being able to publish the data. So being able to use a connector that actually publishes
the
out
main
to the
functionality I wanted to
IoT
show
service.
you. Obviously, first was being able to...
So in this example, obviously we're using AWS as our example, but we have examples and ways to use it for other services like Azure IoT or SAP IoT and IBM IoT. For those type of IoT services, it's probably best to use the general MQTT service that's on the App Store. And if you simply search for that, you can add that into your project. So it's very similar to the AWS IoT example. The AWS IoT example just has a bit more features that are specific for AWS. So let's switch back to our things. So obviously I've covered those topics. Is there any answers and questions?
So thanks very much, Simon. That was a very good presentation. You can now ask your questions in the questions window in GoToWebinar. So I'll give everyone some time to come up with a couple of questions. If you want to know anything about IoT, about this sample app that Simon showed you, you can ask them right here, right now. Or if you want to follow this tutorial, you can go to the Mendix documentation at docs.mendix.com and just search for building your first IoT app, and you'll get all of this step-by-step right in front of your screen. So you can do it yourself, and you can build this IoT app in just a couple of steps. All right, so we have a first question by Pim. The amount of data is growing if you capture all of the IoT data. So will the default Postgres database handle this? And do we have any best practices with big data?
Okay, great. So yeah, that's a very good question. Obviously, these devices do generate a lot of data. That is why in the applications that we've built, we've actually built a scheduled event which will actually clear the data. So we're only storing the last kind of 30 seconds of data. That's purely because in the Mendix side, what we really are concerned about is actually doing the logic on the application. So actually being able to trigger and build experiences. We don't want to be generating and storing historical data. If you want to store historical data in a kind of big data format, then obviously you could write that data out to a big data solution to actually able to store that as well. Also, some of our other customers and clients have decided to do all of the triggers and alerts on the actual IoT side. So being able to do those alerts on AWS IoT, for instance, or Azure. So they have big data solutions. You can do the alerts and triggers on AWS and the logic there, and then simply push that then to Mendix. So you could still use kind of MQTT topics, but you could reduce that by just using it for alerts. So for instance, if you wanted to send an alert to the Mendix application, or there's an alert on the AWS side, for instance, if the light's gone too high, you could use MQTT just for the alerts part rather than the actual data part. So yes, we're not a big data solution. It can handle obviously a fairly large amount of data, but if you're looking at multiple different sensors and so on, yeah, we would advise using a big data solution and only storing the last kind of few seconds of data within Mendix.
All right, great, thanks. We have another question by Gil. He says, I understand why we listen to sensors, but I don't understand why we need to send data and publish to broker.
Yep. Okay, yeah, it's a good example. So one example that is often used when demoing these sort of MQTT and IoT functionality is, for instance, in a home system, for instance. So you have a home automation system and you have a security system, for instance. You might want to have an application where you press a button and it will then, based on that button click, it will actually be able to lock the door, for instance. Also, when you have these sensor data, they're all publishing as well. So publishing on the Mendix side could be useful if you're wanting to use the same publish method that a device is using, for instance, or you wanted to communicate multiple different devices. So MQTT is useful anyway, even if you're not sending big data, because of the subscribe and publish methods. So if you publish data on the Mendix side, then all items that are subscribing to it will then be able to listen into that information. So like in my example of a home automation, if you click lock my doors, for instance, it will then go off to the sensors and then actually lock the doors. So it could be 5 or 6 different doors that are listening into that particular one topic.
All right, great, thanks. So you just showed this IoT app, and you built this stuff in like within half an hour. But a lot of this stuff is already in place. If you start your first IoT app, how much time would it really take to build something that generates some nice results and actually has some use for the business, for example?
Yeah, so the key thing is obviously you need to have some form of data. So being able to have some form of sensors is obviously important. And there's lots of useful sensors out there, useful example IoT connectors that you can connect into for sample data. We are using in our example a system called Texas Instruments. So if I just get a picture up of those so you can see what they are. So the Texas instrument has a number of different sensors on it. So it has humidity, it has temperature, so on, and things like that. So it has multiple sensors, and it allows you to easily integrate into your IoT broker. So the IoT brokers are easy to set up as well. You can just go on to AWS or to go on to IBM, and you can set your own IoT service up for free. And then to connect it up into Mendix, then you simply have to obviously do the subscribe method, which I showed earlier, and then the publish method as well. So it's pretty simple to be able to connect it up. You can probably do it in a few steps if you've got the sensors already set up and the IoT broker already set up.
All right, great. And what about the team size? So if you're starting an IoT app, how many people would you need? Can you do that on your own? I mean, I think you can, but it might take a long time.
Yeah, I think the key with the IoT applications is there's quite a few different moving parts. So you would probably need some form of team to be dealing with the actual hardware part and the sensors part of it, because if you're monitoring lots of IoT type data, you need obviously a team dedicated to more of the hardware part of the application. In terms of actually building the experience in Mendix, once that data is in the MQTT broker, then it's fairly simple to then build that application. So you probably only need a team of 1 or 2 Mendix developers to build a Mendix application on top of this IoT service. But obviously you've got to have other teams interacting together to be able to get that data and be able to create the communication and so on.
All right, great. So we have a question here from George. With the wave of IoT technology coming, does Mendix have a reduced cost model somewhere between the free version and the full enterprise version that will be more independent for small developers to use Mendix to build IoT apps at a more reasonable cost? Because the free edition, well, it's good, but it's really only good for building prototypes.
Yes, that's a good question. It's probably one I can't answer as not being part of the sales team. So that's probably one we'll have to come back to, because that's based on licensing and things like that.
Yeah. All right. Thanks. So, is there anyone else who has any questions for Simon? Anything about the IoT app brokers, building this stuff on the technical side, or maybe what uses IoT in general for your business? What can you do with it, and why would you need it in the first place? Because IoT is this buzzword thing. So I'll just give people a minute to think of any questions.
I went quicker through my application than I thought I was going to.
Yeah, no problem.
So
it's okay though, because we have the recording, so afterwards people can just go to the webinar page and watch it at their own pace, just pause it. And of course we have the tutorial, so they can build it themselves.
Sure.
And they have your guidance in video.
Definitely.
Yeah, with your explanation, so that's good too.
So maybe it's a good idea to give you some background and some bits on how I built the dashboard. So that's always quite useful. So actually the dashboard here is, we're using a number of different widgets. The first one obviously is the Chart.js widget. We've got a Google Maps widget at the top here. And then we've got a number of just different sensor data that we're pulling through. The data is being refreshed, so there's a microflow timer that will refresh the data on the page so that we can get the live updates from the data that's coming in through the background of the application. So that's how we kind of built the application, and in the application as well we have obviously the alerts as well. So the alerts on the mobile phone are triggered via the push notifications, and we make those decisions using a microflow in the background.
All right. Okay, so we have another question from Jaap. He says, how do the devices communicate to the broker, especially from within a container?
Okay, yeah, so there's a number of different protocols you can use. In the example that we're using at the moment, the sensor tag actually communicates over Bluetooth to a mobile phone device, and that mobile phone device then sends the data via MQTT to the broker. You can do it via other methods as well, so there is technology like Zigbee and a few other different protocols, which are lightweight protocols which allow you to communicate with a central hub. So if you imagine in an example like a home automation, most home automations will have a central broker hub which all of the devices will communicate to, so under a particular protocol, which is you know something like Bluetooth or something, a low range radar sort of kind of signal. And then that device hub will then communicate with an IoT broker. So if we have a look in our example, I had one earlier here. So usually when we look at the kind of communication, this publish step here is usually done by an intermediate step, especially if you're on a container, for instance. You might have obviously a number of sensors and those might have no connection to the internet at all. So what usually happens is they have a central device management system that is close to the sensors, probably on each container or on a set of containers, which will then receive that sensor data and will store it until it can then submit it to the actual broker. So you might have your own broker network essentially on the ship before being able to actually send it to a cloud environment.
Okay, thank you. So John asks, does the IT broker charge for the use of the brokerage services?
Yes, it does. So it depends on each of the broker service. So usually it's done by messages. I don't think they charge by devices, but I'm not entirely sure. So usually it's per number of messages, but you get quite a bit of bandwidth for testing. But yeah, you'd have to look up into the different services for that. I think their price models are pretty clear anyway. So
yeah,
I think it's usually just like a bulk of X number of messages in a window. So it might be 5,000 in a month, for instance, something like that.
All right, we have a question here from Brandon. What would be shown if the IoT device went down? So is there a specific error handling built in the microflow activities?
Yes, so if you don't actually send anything to the MQTT broker, it doesn't matter. So the subscribe method will just listen into any data that's sent it. If there's no data, then it just doesn't execute that microflow. So it's not like if we don't send data to it, it's going to fall over. I have built some logic into it to have some standing data. So in my application, just for demo purposes, what I did is if I turn off the push to cloud now, so I'm actually turning off the sensor data, you'll start to see that the graph will flatten out, and then we'll get some example sample data eventually. So if no data is being sent, it just simply doesn't execute the mic flow.
Okay, I think that's
So
clear.
you'll see in a second. It will there'll be a new graph because it will just use some sample data I've just added into the database. So here we go. So now this is just a sample graph.
Yeah, exactly. All right, I think those are the questions for today. So let's round up. Thank you all very much for joining. It was a great presentation, and we'll send you an email with a link to the video, and we'll post the questions and the answers on the webinar page. And if you have any questions afterwards, you can always ask them on the forum or contact someone at Mendix. So thank you all very much, and see you next time.